Okay, welcome back. We're going to be doing movement event 4 today. So movement event 3 essentially just lets us lock in our direction and to lock in our first movement row, which we are currently doing. Let's check it out. We're doing it with a rendering of a dark green. So we lock it in. This is our movement event 3 we did yesterday, and if we click one of these, we've got all legal moves at the moment being false, all false legal moves. So no legal moves, and our movement origin is locked in, and our first movement is locked in at 2-3 in this scenario. So we've got the right direction being locked in, which will help us in our movement 5 and 6. But for now, we're going to if we get rid of this, and we can add our movement event 4 logic. So there's our movement event 3. Now if we're in movement event 4, what do we gotta do? This is our pseudo code for what we're trying to do here. And we need to drop at least one stone in grid, which is true. But we could drop all our stones, so we have to keep that in mind. So it's looking like it won't be too difficult. Let's just try to do... We've got the index of where we need to drop that stone, so it should be simple enough. So I'm going to look at what we're doing to drop stones in our movement 2. And we do have a... We do have a lowest milestone stack order, and we do have a dropped-in movement origin, so we'll need to keep track. Our lowest milestone stack order is still a variable. We'll just need to increase it if we drop a stone and decrease it if we pick up a stone, and that is so that we know which stone we're picking up in our mouse stones. So let's go ahead and say we know that we need if love is pressed, right? So love dot so we know we need to be able to drop stones, and we know we need to be able to pick up stones. So let's say what happens when we press down. How do we drop a stone? Well, we would need to copy our lowest mouse stone index from our mouse stones class. Let me see if lowest... Oh, you know what? Lowest milestone stack order is just a variable here in our play state. Yeah. So we shouldn't need to do this dot operator anywhere there, but we would need to say that the mouse stones dot members, which is what's holding all of our stones, at the index of our lowest mouse stone stack order, the field of our not only type, I want to keep the same order. So we've got here we've got color type stack order. So let's do the same thing, color type stack order. So color, I'm just going to put it here, stone type, stack order. So when we press down, we need to take the member, our lowest member of our mouse stone, we need to copy all of those variables into the top of whatever movement origin grid. So if there's one occupant in our origin grid, we need to copy over, we need to assign stack order based on how many occupants are in that grid. So we can say grid we're putting it at, we know is at our first movement row and our first movement column. We know that's the grid, but we need to tell it which member, because right now this is an occupant, and occupants don't have stone control, only members do. Not stone control, stone color is what I mean. Oh lordy, okay. So which member do we need it at? And the member we need it at is gonna be the top, you know, it's gonna be one number bigger than the highest number of occupants. So what we can do, we can say, we did this just like we did it over here. For a down press. Oopsie. We drop stones in our movement origin. How do we do this? Maybe this is not what I was thinking. Thinking this is wrong now. Oh no, we increment the occupants and we decrement. Okay, but then this is what I'm thinking of, occupant index. So how do we drop? Oh, we do it right here. We assign. Yep. Now, this isn't exactly right though. This isn't right. This works if yeah, I don't think this is actually right. Because right here we're dropping a mouse member, we're copying the mouse member into an occupant index. But the occupant index is just the number of occupants that are in that square already. So how does that even work? Well, it kind of works because we increment the occupants right off the bat. So this is actually this number here is actually the correct index. Okay. So I guess it does make sense. We're just a little sneaky with incrementing the occupants and then setting this thing called occupant index equal to current occupants after we've incremented it. But I'm thinking if we pick up, I'm thinking this doesn't work if we pick up from a 10 stack. I guess let's test it. Well, no, it's been working. We've got more than a 5 stack. Let me just copy this out real quick. We need okay, no, it is working. Okay, it's just a little sneaky that we did that there, but we've already got a variable for this purpose, which I guess is okay to repurpose here. I say that like I did because we were repurposing variables in our first try of this test, and that's all this code here when we reused our move locked origin row or move locked row and column, which I don't know exactly what caused our bugs, but I'm thinking that's what caused our bugs. So I'm a little hesitant to redo this, but there shouldn't be a problem because we're just going to be updating this occupant index with the correct index for our grid. But we don't want to just check if we press down. We want to also make sure that we actually have an occupant to drop. So if we have more than one occupant, actually, I guess this would be greater than 0 because we are allowed to drop all of our stones in this grid. So if it is equal to 1, we should still be able to drop a stone. So what we're going to do first is say that our mouse stones dot occupants will get decremented. And we're going to be saying that our grid at that position of our first movement will actually get incremented, and it's the occupants field in that occupant class. So it's occupants. We're going to say it's increased by 1. Then we're going to say, hey, our occupant index is now going to be assigned to our incremented occupants. And now this line of code when we say at members occupant index, this occupant index is going to be one higher than how many occupants were just in that grid, meaning the grid with a stack order one higher, meaning the shrinking one will go on top. So we're going to be putting our lowest milestone stack order onto there, and then we'll need to decrement our lowest milestone stack order, actually increment it. Because as you drop stones, the stack order will rise. So that's why we need to rise it or increment it upon a drop. Then we want to copy over the stone type and the stack order. And we want to move it into that same grid. So we say stone type. And we say stack order. This is wrong. So once we copy our lowest milestone into the top of our first movement grid, we need to nullify the milestone at that position so that we don't render it anymore. So we say that this value now gets nil, because we already copied it to its correct spot, and we know that the stone type and the stack order also for that member need to be wiped to nil. Then we increment our lowest milestone stack order. Like we're missing something. If we take a look at our movement 2 drop, we also, that's what we're missing, we also keep track of how many we've dropped in our grid so that we can ensure we only are able to pick up as many stones as we've dropped. So let's put this, and let's put that we have a variable called dropped in first movement, and this gets incremented by the time we drop one in there, and then pressing up will actually decrement that, but we'll use that here. If up is pressed and dropped in first movement is greater than 1, meaning we've dropped at least 1 stone, then we can pick up a stone. And we would need to do much of the same stuff, but let's test to see if pressing down will get rid of our lowest milestone stack order when we are in a movement 4. So let's see. So we've got 5 occupants. Pressing down crashes it. Attempt to perform arithmetic on a table value. So 632 is where it's not liking it. Yep, this was a table value and this should have been a field that is an integer. So we fix that, and let's see. Okay, we are able to ignore the stack order at the moment, but we are in fact able to drop our stones there. So we need to assign stack order based on how many occupants there are. So because right now we don't want to copy the old stack order. Gosh, you know what? Fuck. This was a tough thing we had already figured out in our old code. We need an original stack order, which we do have. Let me take a look. Let me take a look at our old code and see what we did for that, which was like right here. So this is picking up stones from movement origin. We don't really, yeah. I guess we do have to keep track of that. No, okay. I'm thinking that our movement origin, when we pick it up, we can't have a different stack order because we can only pick up 5 from the top, and if we drop those back on, it'll keep the same stack order. So I don't understand why we would have had to use our original stack order in our first movement, or in our movement origin space. The first stones drops makes more sense to me that we would have to do it there. But we're not even doing it there. This is, okay, so yeah, actually, this is the one I was thinking of. What is this one then? You know what, this is just assigning, okay. We need to do this. We need to give our member a field populated of original stack order and populate that with its original stack order, so that when we're moving stones on top of a different stack that we came from. So like, yeah, we need this. It's hard to explain. We need this though. This is for the adaptive sizing when we're dropping stones onto a grid that is going to change the stack order size, which is going to be almost always the case. When it's not like that, that's not the case if we pick up less than 5 stones and we move onto another grid with no stones on it, which isn't that often in gameplay. So what we're doing here is as soon as we're populating our movement origin, we're also populating the original stack order in the milestone members, because we need to be able to know how to render them once we pick them back up again, because they shouldn't keep, you know, if we drop them and they grow, when we pick them up they need to shrink again. They don't need, if they stay the same size, it'll throw everything out of whack. So we need to do this. So we're going to be, wherever we are doing our movement origin row, wherever we are assigning our movement origin row in our new code is where we need to assign this. Wow, okay. Here. So look, we assign our movement origin row. We need to also assign, see, and this is messed up because this is in a loop here. Hold on. Look, we're doing this for every occupant. Okay. So we do this under what is this for? Is this once we click it up? Yeah, once we click on a legal move, we copy all those values. So come on, where we're at. This implementation we have is much better than our original one. We just forgot to do one thing. And we forgot to, when we copy over the stones into our mouse stones, we need to assign our original stack order. So we have access to that variable. So what we're saying is, hey, the variable that was our stack order gets assigned into this new field called original stack order, because our stack order becomes nil once we drop stones. So we need a way to be able to recall this original stack order so we can reapply its original size once we pick the stone back up, if that makes sense. So now that we've got our original stack order, and we didn't have to do this for our movement origin because our stack order is the same, because you're only dropping a stone onto the stack it came from, so its sizing will be set appropriately. It's just that when we're going into a new grid, we need to think about that. Okay, so we've got dropping our mouse stones into the first movement working. And we're able to drop all of them, which is good. So I guess we work on picking them up now. So if up is pressed and we have dropped a stone, then we're going to allow ourselves to pick up this stone again. But this isn't exactly right. Actually, no, it is right as long as we remember to decrement this dropped in first movement. So let's just do that now. Dropped in first movement gets decremented. And then I guess we would need to also decrement our lowest milestone stack order so that we can index the correct one to drop next time. And then we basically do the reverse here. Well, we know we need to increment our milestone occupants. And we need to decrement our first movement occupants. Okay. We're gonna say we update this to be one less. And then what do we do with this? Occupant index. I don't think we need this. We just need to assign the original stack order. So yeah, this is just so that we copy them onto the top stone, but now we're just trying to copy the top stone. So we can literally just use how many occupants are in there. Now I guess since I don't want one huge ugly line here, we can actually do basically the same thing, except instead of doing it once we decrement our occupants. Actually, yeah. Instead of doing it when we decrement our occupants, we want to take say that occupant index gets the amount of occupants before we copy it into our mouse stone. So the top stone index is basically what we're trying to save here. So our first movement row, first movement column, our occupants in our grid before we actually do anything to it gets saved into the occupant index, then we decrement it. But now we're able to use this in the index, just like here, without having this whole line in the index right here, which gets messy to look at and to read, especially since we gotta like scroll over. So I'm just trying to make it a little more readable. This is totally unnecessary, if you want to call it that. It's just that it just makes it more readable. So what do we need to do to pick up a stone? We need to copy the top stone of our grid into the bottom stone of our mouse stones. So we take our grid at our first movement location, and we take the top stone, which we can access by using this occupant index we saved. We take that top stone and we take that top stone's color and we place it into our mouse stones at our lowest mouse stone stack order location in our stone color field. Now I think that's right. Now we need stone type. So we say stone type gets copied into our mouse stone members at that index at that stone type. And then here's the tricky one that we can only do because we fixed that old problem, is we want to assign our mouse stones members in our lowest mouse stone stack order index. We want to assign that stack order not to be inherited from that original grid, but to be actually populated based on its original stack order. So our very same lowest mouse stone stack order, but its original stack order is what we want to restore it to. And then we need to nullify everything from our grid here. So we say this, and this will all get nil. And then we'll test to see if that's working as intended. So let's see. Okay, we're able to drop one stone. It doesn't get bigger, and we're not able to, well, that is so jacked. Oh, lordy. Let me just take this out for now. So we need to assign stack order not based on our old stack order, but we need to give it a stack order that is equivalent to one more than its current occupants. And so we should be able to do this. Occupant index. So we're going to say our stack order of that grid will get updated to be this occupant index. So now let's see if we get the adaptive scaling upon dropping the stones. Yes. See how they grow to be bigger than our mouse stone, and we are actually allowed to drop that many. So where do we all go wrong when we pick stuff up? It might have to do with the slowest mouse stone stack order. We're not able to pick up one stone if we drop it, so our dropped in first movement, that's weird because we are incrementing this. Is our dropped in first movement, oh, you know what? Are we not even initializing this? I don't even know if we initialize this. You know what? We have it. Oh, no, this is an old thing. No, we have it dropped in first movement. I'm going to print up our dropped in first movement here because we should be able to pick that up. I'm pressing up now and it's not being able to pick that up. So we need to be able to do that. We just print up. Is it dropped in first movement? Yeah. And in our movement 4 here, well, I'm gonna just comment out this old code so I'm not scrolling through this all the time. It won't let me collapse it. Come on, man. It won't let me collapse it. Don't know why. I'm so confused. Why do you do this to me? Let me collapse all this garbage, but whatever. Okay, whatever. Let's print up in our debug 2. We'll print up another value. And that value is going to be our dropped in first movement, so we can debug that. And then so let's make sure that is correct. So right now, dropped in first movement is 0 because we haven't dropped anything in our first movement. But when we drop 1, we have 1 there. So we need to be able to pick up that stone, so we actually need to if dropped in first movement is greater than 0, not greater than 1, we have to make sure we've dropped at least one. So now we should be able to pick that stone up at least. Drop it, pick it up. That doesn't work. Jacked. Oh lordy. Okay, let's just worry about dropping for now. It seems to be working on the dropping front. Yeah. Dropping seems to work. I don't know where we're going wrong here. We're assigning our occupant index to be equal to the amount of occupants in our grid. Meaning, if there's 3 occupants in our grid, 3 would be the index of which we're trying to copy over into our mouse stone object, which is what we're doing over here. So I think that's right, but we're not actually, we assign this based on let's print up our lowest milestone stack order and see if that is working appropriately when we got our drop and pickup logic. So let's see if our lowest milestone stack order is working appropriately. So gonna need a 3rd page of debug info here soon. So putting another line, and we're putting in lowest milestone stack order. You know what? We already have that over here, so let's cancel that. We've already got that on our first page, so let me just test that. Should be 5 when we pick up from a 10 stack, which no, it should be 6. Yeah, this is right. It should be 6 when we pick up from a 10 stack because our bottom stone is a stack order of 6. So when we drop 1, it should be higher. So a 7, yep. And then when we pick 1 up, it should go back to 6, which it does. Not sure what's happening here. Our lowest milestone stack order is right. Our dropped in first movement seems to be right. Now we nullify the occupant index of our grid, and our occupant index, this is actually wrong. We want to nullify the old occupant index, which is this +1. Let me just see if that fixes us. Nope. Why would picking up a stone delete a stone from our mouse index? That doesn't make any sense. That doesn't make any sense because we're not even... What? Fuck. Instead of doing this occupant index, let's do it the old-fashioned way. So when we pick up a stone, you know what, the last thing I'm gonna do is do our occupant update. So we're gonna do the things first, then we can worry about our occupant update. So once we pick up a stone, we're taking the index of our topmost stone, which in this case is what? Our topmost stone would be the amount of occupants in this grid. So we're saying here .occupants is going to be our actual index for members. And same thing with here. This is what I try to avoid by saving that file, so we don't have a huge old thing to read, but it's whatever. Now, we're copying... Oh, see, this is where we're doing it wrong. We're putting it into the lowest milestone stack order, but we want to put it into one beneath the lowest milestone stack order. Just beneath our mouse stone, and then we need to nullify that occupant's stone color, stone type, and stack order. So maybe now we'll be able to pick up a stone and have it revert to its original size. So we drop a stone, attempt to index nil value, always the issue. 652. I'm going to redo what I tried to do with one change. We're going to have the occupant index here, sure. This is totally wrong. This is totally wrong. This. There. That's right. Now I'm curious if we change our lowest milestone stack order to be less than 1 right off the bat, then when we put these into the lowest milestone stack order, it'll be the appropriate spot. So let's say that we do this right away. Let's see that. Really? 654, index no value. What's a nil value here? We've got this. We've got this jacked, dude. This is supposed to be column. Why do we do this? Okay. Such a stupid mistake. Okay. Now let's see. Watch it still be busted. Drop. Still busted. 654. We've got it right here too. Gosh. Dummy, 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 dummy. Okay. Okay, drop one. Pick one up, still crashes. At 6:54. Wow, really just still crashes here. What are we doing wrong? Let's see what happens when we look at this line of code. We do the -1 here. So look, let's just say drop to movement origin. Yeah. So look, here's our other code we do. First movement row, first movement column, dot members, occupant index. It's the same shit. It's the same shit, except we're not trying to index this just yet. Why does this happen? What am I missing, dude? What is a nil value there? You know what? We're actually not incrementing the occupants once we drop it in. Yes, we are. Yes, we are. Let me literally just... I don't know what else to test other than test this. Let me print out our first movement occupants. Okay. Let's make sure that's right. So, first movement occupants 0. It seems to be working. I don't know why. That isn't the problem. But we still crash on the same line, 6:53. So what is... I don't know what's happening, man. Dude, really, right here we do it again. God damn it. That screwed us up so bad. Okay, let's hope it works now. Can't believe we messed that up like 6 times. Okay, I'm gonna press up. And now we crash on a different line. Stack order is a nil value. Field stack order, so on number 28. Here. Jeez, okay. Let's try it. Really? So look, if we take out our stack order, let's see what happens. Really? Let me see what we're doing. We had this working, you know, before we went to do it from scratch. So that's when we first initialize it. So look, we say our original stack order gets... Oh, we have to copy over the original stack order. No, we shouldn't have to. Well, yeah, it makes sense to. It makes sense to. So when we copy a stone, we copy over we need to copy over the original stack order. You know what? Maybe this is why it's messed up. Copying the same variable into both stack order and original stack order. Now when we drop or pick up a stone, we need to also copy that over. So I'm gonna say that we need this. We need this original stack order. To be copied into the original stack order over here. So that we can nullify our original stack order. Now what? Well, we drop it. We need to copy over. See the stack order. Guess that's right. Occupant index gets inside that stack order. I guess that is right. Because we're not trying to copy over. Yeah, we need to copy over the original stack order. Okay. And then last, oh, you know what? We literally had this turned off. We might have just done a bunch of crap we didn't need to, but crap. The idea between copying over the original stack order, no, it makes sense for us to copy over the original stack order because we don't necessarily actually, if we leave original stack order populated in our empty, otherwise empty mouse zone member fields, all we have to do is kind of assign stack order based on that value, and then we wouldn't have to pass data each time, but I kind of like it passing it each time just so we don't mess up anything. But this is also backwards. No, it isn't. Instead of copying over this original stack order into the other field, we're gonna actually copy over from the grid, because now that we're shifting it, we can kind of keep it consistent like that, and we can say that our member's original stack order gets copied into our stack order now, and then we need to copy over our original stack order, I guess, again. Okay, let's see if we crash. Hey! So I'm pressing up, we don't crash, we drop 1, drop 2, we can... Okay, nice. Cool. Okay. We're working. So... I think the problem was somewhere where we were assigning stack order based on that same instantiation's original stack order, and that was just not working for some reason. So now we just copy over our original stack order as well. I don't think we absolutely need to do that, but it wasn't working the other way, so I guess it's fine to just continue doing it this way. There's a lot about programming I do not know at all, and I don't know any good hygiene for code bases. You know, I'm still figuring that out, so I don't know if that's a good idea or bad to kind of manually copy over data like that each time. To me, it makes sense. but we would also want to nullify the original stack order. As well here, if I'm not mistaken. So yeah, we nullify it there too. Okay. We're not quite done. We're not quite done with this yet. We've got to do a couple of things. We got to make it so that enter locks in how many stones are dropped in there. If enter is pressed and we have no occupants, that means it's a new player's move. But I would just implement that now, but the other thing we have to do is check whether or not the first movement space is on a edge, because if it's at the edge of the board, we must make the player drop all their stones. Our mouse stone occupants must be 0 in order to have pressing enter do anything. So we'll have to do something like, where is our notes? This is exactly what I typed last time. We ensure all stones dropped in. Okay, yeah, so we need to also so when we add enter pressed, check if edge, if so don't swap players. So then it would, the corresponding one would be like, if enter pressed, if not edge piece, then movement event will get 5 or whatever. So we're almost done with movement event 4 after today. I'm just feeling low energy. I'm not really up to doing much more, but we can move stones and they adaptively size in the first movement grid, and when we pick them up they adaptively size back to where their original size was, which is what we want. Then when we hit enter like that, we need to swap if there's no occupants, and then if there is occupants and it's not an edge case, then we need to render our next legal move, which depends on our direction lock, which this is a top lock, or an up lock I called it, so that this one would be then that would be an edge case. Then we would have to make sure they drop them all, but we'll get there as we keep chugging along. We're almost back to where we were by the time I refactored all of this code, so we're almost caught up. We just have some more testing to test before we say that we finalize this movement 3 logic. No, movement 4 logic. Yeah, movement event 4 logic. So we can at least commit, and we can say added most of movement event 4 logic, just missing enter checking, and we could push it. And I will see you guys tomorrow. Hopefully we'll finish this movement event 4 tomorrow with this edge checking, because if it's an edge, we need to make sure we drop all our stuff, and then when we hit enter, it needs to swap players. But if it's not an edge, then if we drop all occupants, then hit enter, then we would still swap players. But if it is not an edge and we have more than one occupant in our mouse stones when we click enter, then we need to lock in our second movement grid, and then we would switch to our movement 5. Then we can get started on movement 5 logic. So we got a couple more things before we finish that up, but we're making good progress.